Hello everybody, this is your teacher Abrar sir. Due to extreme pollution, we have been compelled to stay indoors and we won't be coming to schools on 4th and 5th of November. So here is our chance to have a small flipped lesson. So please go through this video carefully. It's a small video class on the topic of surface area volumes, the 13th chapter in our NCERT book. So you are aware of the basics, that there are these 6 figures: cube, cuboid, cylinder, cone, sphere and hemisphere. So I'll expect you to know the surface area and volumes of these structures. So what is actually from class 10th is the combination of figures. Let's say there is a cone and above the cone there is a hemisphere attached to it, exactly attached. So we can say, and we can see actually, that the radius of the cone is also the radius of the hemisphere. That's why it has been attached comfortably. So if the total height of the object is capital H, from the capital H, if you subtract the radius r, then you'll get the remaining part, which will be the height of the cone. In this case, it is capital H minus r. So these small ideas can help you in cracking these questions. Similarly, if there are many small coins piled together to create a large cylinder, if you know the height of each coin, and there are n coins, so n times h will be the capital H, which is the height of this entire object. And if you know the radius of each coin, so pi r square h will give you the volume of this structure. Let's look at this. There are 1, 2, 3, 4, 5, 6 cuboid joined to each other, back to back. If the length of each is L, breadth is B, height is H, they're connected in such a way that there are 6 L's actually forming up. So if you have this idea, then you can easily find out the volume of the structure as well as the surface area. Here we have a cylinder, and on both sides we have hemispheres attached. So one thing to understand is that the radius of the cylinder will also be equal to the radius of the hemisphere. So if you know the volume of hemisphere and the volume of the cylinder, just add them and then you will get the volume of the entire structure. Here we have a hemisphere and a cylinder and a cone. The beauty of the picture is that the radius of all three structures will be same. And I'm sorry for this, this is not R, this was actually diameter. So R will be from the central line to the surface. This is the radius. Okay, same radius. So we can have a better idea of the picture. And finally, we have this topic, conversion of shapes. I'm taking a small example quickly. Let's say there are some workers who dig out the earth. They're trying to dig out a well, and they reach the bottom of this particular well, and the soil is taken out from the well. A good well is created, and the soil is actually dumped around this structure only, so that it completely covers it and it looks like an embankment. Okay, this part is left because the well is beginning from here, and the height of the embankment, they can ask you to find out the height, and the inner radius of this embankment will be same as the inner radius of the well. The outer radius may be found out or it may be given to you. So you can understand that this extra new structure that has been created is a combination of two cylinders. One, this large cylinder, and one small hollow cylinder, which is not there actually. So from the volume of large cylinder, if you subtract the small cylinder, you will get the volume of the embankment, which is nothing but the entire soil that had come out from this well. So it's a good a situation of conversion of one cylindrical shape into another cylindrical shape. Okay, another concept which is highly used is the volume equal to area into height. If you know that there was a land, or there was uh, a surface with an area A given to you, if water comes over it, a lot of water comes over it, and the height of the water is found out to be h. It can be centimeter, meter, depending on the scenario. So you multiply a h times, which means a into h, that will give you the volume of the entire water. It's a very nice concept, and it is used in many a question. And this is also one of the favorite questions: water in a pipe. So water, while flowing in the pipe, flows in cylindrical form, and it is falling into this cylindrical tank whose radius may be given to you, height may be given to you. So ultimately, how much of water has to come out of this is nothing but pi r square h of this tank. So conversion of this water into this particular volume is something to understand. And then there are questions of coins melted and recast into another figure. So the point to understand is that the volume of objects remains same. So if there are 50 coins melted, which means 50 times pi r square h is converted into, let's say, a huge cuboid. So L into B into H. The volume on this particular side will be same as volume on this particular side, because the matter is same after all. So please apply these ideas to solve some questions, and at the end the homework for you people would be NCERT exercises 13.2 and 13.3. I hope this video was able to help you to some extent. Otherwise also you are suggested, and you are expected to find some other good videos, some more professional videos I mean to say, and take help of your elders and do these exercises. I hope you are maintaining good health, and see you people on Wednesday, the 6th. Bye.